Sine of x equals 1/2. Switching to the computer here, there's a graph of sine x, and there's a graph of y equal 1/2. How many answers does the equation sine x equal 1/2 have?
Well, in this example, it's like 4.
Well, so right there you can see 4, but that's not all of them, is it?
Infinity.
It has an infinite number of correct answers. How come?
Because it just keeps going.
Yeah, this sine wave keeps going, doesn't it? This is only between negative 2 pi and 2 pi. The sine wave keeps going, so it's going to hit again here, and it's going to hit again here, and it's going to keep going, it's going to hit again and again, and it goes down on this end, it goes down, it comes back. So how many answers are there? There are an infinite number of correct answers. So how are we going to write them all?
Just do all reals.
Well, it's not all reals, though.
Oh, no.
It's not all reals isn't the answer, though, is it? For example, x equals 0 is not an answer. Because if I put 0 in, I get sine of 0 equals 1/2. So here's one answer, right here. What is that answer? Sine of what gives you 1/2? Pi over 6 is one answer. Okay. What about this answer right here? This answer is just a little bit smaller than pi. What's that answer? It's the answer in quadrant 2. The answer in quadrant 2 would be 5 pi over 6. All right, let me expand my graph a little bit here. Change this to be 4 pi. Okay, so we had pi over 6 and 5 pi over 6. And then the next answer comes right here, which is just a little bit past 2 pi. What can you tell me about that answer? 11 pi over 6. 11 pi over 6 would be just a little bit smaller than 2 pi, because 12 pi over 6 would be 2 pi. So this is just a little bit bigger than 2 pi. So it's 13 pi over 6. But how is it related to pi over 6? Pi over 6 is the reference angle. What happens if I take pi over 6 and I add 2 pi? I get the next answer, don't I? So if I know pi over 6 is one answer, to get another answer I can add 2 pi. And then to get another answer I could add 2 pi again. I can keep doing that. What about this one? This one was 5 pi over 6. Where would I be if I added 2 pi to this one? Well, I would do one complete cycle, and I would hit that one right there, wouldn't I? So there are an infinite number of answers, but we really only need to find 2 of them. For this problem, I really only need to find the answer in quadrant 1, which is pi over 6, and the answer in quadrant 2, which is 5 pi over 6. And then how do I find all the other answers? Add 2 pi, add 4 pi, add 6 pi. Or I could go backward. I could go here, and I could subtract 2 pi, which would put me there, and that would give you another answer. So, there's an infinite number of correct answers, but we really only need to know 2 of them. So here's what we're going to write. We're going to write one of the answers is x equals pi over 6. And then we typically write this, plus or minus 2 pi k. And what does that mean, plus or minus 2 pi k? K is a constant. K could be 1 or 2 or 3 or 4 or 5, which means I add 2 pi or I add 4 pi or I add 6 pi. Basically, we're finding all of the angles that are coterminal. That would be the fancy word. And then we find the other answer. The other answer we decided was in quadrant 2, and we said it was what? 5 pi over 6. And then I write plus or minus 2 pi k, which means, again, add 2 pi, add 4 pi, add 6 pi, subtract 2 pi, subtract 4 pi, and there's all the answers. Questions on that?
Will it always be 2 pi?
Will it always be 2 pi? That's an excellent question. No. give you another example. How about tangent x equals 1? Let's go to the computer and draw a graph. Oops. Tangent of x equals 1. Once again, how many answers are there? There is an infinite number of correct answers. What's the first one? Pi over 4. You look on your chart, tangent of pi over 4 is 1. So here's the first answer. This is pi over 4. Where's the next answer going to be? I would add pi. Why would I just add pi? So the next one, if this is pi over 4, I add pi. The next one is at 5 pi over 4, which is in which quadrant? No. Tangent's positive in quadrant number 1. And tangent's also positive in quadrant number 3. So if I want tangent equal 1, my answers have to be in quadrants 1 and 3. Alright, so here's pi over 4. If I add pi, I get the answer in quadrant 3, which is 5 pi over 4. You get the next one? Add pi again. You get the next one? Add pi again. So if I'm dealing with tangent, I add pi instead of adding 2 pi. What's the difference? Why for sine did I use 2 pi, but for tangent I only use pi? Let's go back to that sine graph. Oops. Didn't mean to do that. What did I do? How long does it take to make one complete cycle for sine? The period is 2 pi. How long does it take to make one complete cycle for tangent? It's only pi. That's the difference. So, if we're dealing with sine or cosine, we're always going to have to add 2 pi because the period of sine and cosine are 2 pi. If we're dealing with tangent, then we only have to add pi. So for tangent, we really need to only find one answer. X equals pi over 4. That's the answer in quadrant 1. And then I add or subtract pi times k. Because the period is pi. So if I take pi over 4 and add pi, that's going to give me 3 pi over 4. That's going to give me the answer in quadrant 3. If I add pi again, that's going to be back to pi over 4. It's going to be one complete cycle and then over to pi over 4. So for sine and cosine, you always need to find 2 answers and then add 2 pi k. For tangent, you only ever need to find 1 answer and then add pi k. And it has everything to do with the periods. Questions on that? All right then, how about cosine of theta is negative 1/2. I'm going to need to find 2 answers. What are they? What's one of the answers? Negative pi over 3 is not a correct answer, but you're very close. Because negative pi over 3 is in quadrant number? Pi over 3 is in quadrant number 1. Negative pi over 3 is in quadrant number 4. Is cosine negative in quadrant number 4? No. Crap, it's not. Cosine is positive in quadrant number 4. So pi over 3 is the reference angle. But what quadrants do I need to be in? 2 and 3, because cosine is negative in 2 and 3. So my reference angle is pi over 3. How do I get to quadrant number 2? How did we do it in the last section when we were dealing with cosine inverse and we wanted to get to quadrant number 2? Pi minus pi over 3. So one answer is going to be pi minus pi over 3 plus or minus 2 pi k. Any revolutions? And pi minus pi over 3 happens to be 2 pi over 3. So there's one answer. And then how do you get to quadrant 3? Think of a picture. You just add pi. Here's my angle pi over 3. How do I get this angle down here in quadrant 3? Well, it's half of a revolution more, isn't it? So I'm simply going to add pi. So this one's going to be pi plus pi over 3 plus 2 pi k, plus or minus. So theta was pi plus pi over 3. Four pi over 3. Lots of fun with fractions and radians, isn't there? So our answer would be 4 pi over 3 plus or minus 2 pi k. Lindsay.
How do you know what pi plus pi over 3 is?
How do I know that? Because I took pi plus pi over 3, and I thought of that as being pi over 1. And then I got common denominators, so I wrote this as 3 pi over 3 plus pi over 3, and I added my tops and I kept the bottoms alone.
And that's what you're doing when you're subtracting.
When I subtracted, I did the same thing. I thought of pi as 3 pi over 3, and then I subtracted.
Okay.
Yep, always got to have common denominators. Other questions? Okay, how about sine of theta is minus square root of 2 over 2. And in your book, I noticed in most problems, they ask for two things. They ask for the answer in degrees, and they ask for the answer in radians. So we'll do both for this one. Although I think most of you will find degrees much easier than radians. So I did radians first. All right. What do you do? Pi over 4 is the reference angle.
So you do pi because you're in
Okay, which quadrants do we need to go to?
3 or 4.
3 and 4. Okay, so if pi over 4 is my reference angle, how do I get to quadrant 4? 2 pi minus the reference angle is a correct answer, but it's the hard way. How did we get to quadrant 4 in the last section when we had sine and we had a negative thing? What did we do? We just made the angle negative. So one of the answers, the answer in quadrant 4 is negative pi over 4. Lindsay?
Why did you choose quadrant 4 over quadrant 2?
I didn't. I'm going to have to do both of them.
Oh, you don't.
But I chose to do quadrant 4 first because I thought it would be the easy one.
Okay.
And then we decided to make it hard, and so I said, well, let's make it easy. The easy way in quadrant 4 is to simply make your angle negative. So one correct answer would be minus pi over 4 plus or minus 2 pi k. And the other answer would be theta is, all right, how do I take my pi over 4 and put it in quadrant 3?
No.
That's converting to degrees, sorry.
Okay. I'm going to take my pi over 4 and do what with it? Add pi, just like we did in the last problem. If you want to convert to quadrant 3, always add pi. So that's going to be pi over 4 plus pi plus or minus 2 pi k. And again, I would get a common denominator for those things, and I would end up with 5 pi over 4. All right, now let's do it in degrees. In degrees, what would my reference angle be?
45.
45 degrees. How do I take 45 degrees and put it in quadrant number 4?
You subtract it from 60.
The hard way is to subtract it from 360. The easy way is
Negative.
make it negative. So one correct answer in degrees is theta is minus 45 degrees plus or minus, not 180, 360. I need complete revolutions. So plus or minus 360 K is how we would write it in degrees. And then I need to take the angle in quadrant 3. How do I take 45 degrees and convert it to an angle in quadrant 3?
225.
I add 180, so it would be 225. I add half a revolution. So theta is 225 degrees plus or minus 360K.
You just added the.
I took 45 plus 180. Yep, you add half a revolution to get to quadrant 3. Other questions? All right. Ready for the hard ones now? What? How about if I gave you 4 sine squared x is 1. What would you do? Divide by 4. That's a wonderful idea. So sine squared x is a 4th. Next. Square root of both sides. So sine of x is a half. No.
Just plus or minus.
Plus or minus 1/2. When you do square roots, remember there are 2 of them. There's always a positive square root and a negative square root. So we need sine of x equals plus or minus 1/2, which tells us what? We need to find the answer in all 4 quadrants. We need all the positive answers and we need all the negative answers. So we need all 4 quadrants this time. I want to do it in degrees first or radians? Radians. Ah, I like that.
We need 8 answers.
Huh?
We need 8 answers.
No, we need, how many quadrants are there?
4.
4, so we need,
4, but you need to put it in radians and degrees.
oh yeah, so that's 8 altogether. So it's really 4 answers, but they're written 2 different ways.
Yeah.
So let's do it in radians first. X equals, what's the answer in quadrant 1? Pi over 6?
But that's.
Yes?
Are you doing degrees or degrees first?
They said do radians. I'm doing radians. I like radians. Too bad. Pi over 6 plus or minus 2 pi k. How about the answer in quadrant 4? Negative pi over 6. You're catching on. Negative pi over 6 plus or minus 2 pi k. Okay. X equals. How do we move to quadrant number 2? Pi minus pi over 6. And again, you get your common denominator, work that out. It's 5 pi over 6. And finally, how do you get to quadrant number 3? Add pi. So it's going to be pi plus pi over 6. Again, you get common denominators, work that out. It's 7 pi over 6. So there's all my answers in radians.
So go to quadrant 3, add pi.
Correct. To go to quadrant 2, you take pi minus your answer. To go to quadrant 3, you take pi plus your answer.
Right. Oh, then I already did quadrant 4.
In quadrant 4, you just make it negative. Quadrants 1 and 4 are our favorite ones. Those are the easy ones. Quadrant 1 is the positive angle, quadrant 4 is the negative angle. All right, same thing in degrees.
30 degrees.
X equals 30 degrees in quadrant 1.
Then 150.
Well, let's do them in the same order. This is quadrant 1. How about quadrant 4?
2, no, 330.
330 is a correct answer. An easier answer would have been negative 30. You like 330? Okay, I wrote 330. Okay. Quadrant 2,
150.
you take 180 minus your angle. 180 minus 30 is 150.
Then 240.
And then the last one, you take 180 plus your angle, which is 210. 180 plus 30 is 210. Questions on that? All right, so that one wasn't too much harder. We just had more answers, right? We had to find all 4 of them. How about this one? How about sine of 2x is square root of 2 over 2. What do you do here?
Can you
Should you put 2 with the 2x formula?
I could, but I think that's a bad idea. And here's why I think that's a bad idea. I could use the sine 2x formula. This would be 2 sine x cosine x.
Well, then you're bringing cosine into it, so.
Right. First off, I'm bringing cosine into it, which seems to make it worse. And then the other problem is I'm multiplying 2 things together. When I'm multiplying 2 things together, I really want the number over here to be 0. Why, when I'm multiplying 2 things together, do I really want the number over here to be 0? Well, it's kind of like back in Math1412. You might have factored something, and why did you want it set equal to 0? So you can set each one equal to 0. If this number is not 0 over here, that doesn't work. So since this is a square root of 2 over 2 here, using that formula isn't wrong, but I don't think it helps.
Do you do what we did in the previous one and then just divide it by 2?
We do exactly what we did in the previous one, and we divide by 2. What has to happen is, forget about the 2x for just a minute. What's the right angle? Sine of what gives me square root of 2 over 2? Pi over 4. So instead of just having x equals pi over 4, I have to have 2x equals pi over 4. So one answer is going to be 2x equals pi over 4 plus or minus 2 pi k. So that's the answer in quadrant 1. But then I need to get the x all by itself. How do we get the x all by itself? Divide by 2. So x is, what's pi over 4 divided by 2? 2? Pi over 4 divided by 2, I don't think it's 2. pi over 8, because I have to take pi over 4, divide it by 2. I think of 2 as being 2 over 1, and I flip and multiply. Well, dividing by 2 is the same as multiplying by a half, so that's going to be pi over 8 plus or minus, what's 2 pi k divided by 2? Pi k. So there's half the answers. What do I mean when I say there's half the answers? Those are the answers in quadrant number 1. Sign being positive, I also need answers in quadrant number 2. So how do I take my pi over 4 and turn it into quadrant 2?
Oh, you take pi and subtract your answer.
I take pi and I subtract pi over 4. What's pi minus pi over 4?
3.
Why are you using pi over 8?
Because I'm going to have 2x equals, I always got to go back to my 2x. And then eventually I'll have to divide everything by 2 again. So I need pi over 4 converted to quadrant 3, or converted to quadrant 2. What's pi minus pi over 4? It is 3 pi over 4. Grace let people talk her out of the right answer.
I said
I know you did. And then you changed your mind when somebody else said no. And then we divide everything by 2 again. So we're going to have x is, what's 3 pi over 4 divided by 2? How do you take 3 pi over 4 and divide it by 2? Flip it and times it by 1/2. So you get 3 pi over 8 plus or minus pi k. There's the other half of the answers.
So what is pi over 8 for?
Well, if I didn't have the 2x here, if I had just had an x from the beginning, then my answer would have been x equals pi over 4. But I had the 2x, so I had to divide by 2. So this gave me all the answers in quadrant 1. Then I need to figure out all the answers in quadrant 2. So I needed the 2x equals to the answer in quadrant 2 is 3 pi over 4. And then I have to divide by the 2 again. So the pi over 8 is just part of your final answer. It's not something that you use repeatedly. Other questions? Okay. Well, let's see. I'm going to steal one out of the book here. How about I don't see one that I like. I'll use one that I don't like. How about 5 sine squared x minus 8 sine x equals 3. Any good ideas? Factor. And how would you factor? You can factor by taking out a sine x, but that's not a good idea. Let me change the problem. How would you solve that equation? Subtract the 3. And then factor, if you can. What if you can't factor? It's a quadratic equation. We can use the quadratic formula. Does that factor? Why did you move the 3 over first?
Makes it
Well, it was quadratic to begin with.
So it's an equal zero.
You always have to have it equal to 0 if you're going to factor. That's correct. All right, so I think we could have a 5y and a y. And then, well, it's got to be 3 and 1 on the other end, right? 3 and 1. Kind of make it work out to get a -8. I don't think so. So it doesn't factor. So what do? We use a quadratic formula. So y equals. I just happen to have a program on my calculator for the quadratic formula. 5, -8, and -3.
You could have probably won that.
Hey,
I don't know.
if you do, I'm off my head.
I honestly thought it would factor, but it doesn't. Yeah, look, it gives me the answers. 8 plus or minus the square root of 124 over 10, or about 1.9 and -0.31. There we go. Gotta get the glare off. All right, so 1.9, -0.31. All right, now back to this problem. How is it different that instead of having a y squared and a y, I have a sine squared and a sine? How is it different? The way you do it isn't different at all. You do it exactly the same way. You bring the 3 over. Then you hope it factors. And if it factored, you would do it the same way you do in algebra, except you would have a 5 sine x and a sine x. And then you would need a 3 and a 1. And unfortunately, it doesn't factor. It doesn't work. So what do? You still use the quadratic formula. Except instead of having y equals 1.9, when you use the quadratic formula, what are you going to have? Sine x. So we're going to have sine x equals 1.9, or sine x equals -0.31. All right, when does sine x equal 1.9?
Never.
Never. How come?
It's out of the range.
It's out of the range. The biggest possible value for sine is 1. All right, so I cross that one off.
Oh, there's no real answer.
There's no real answer for that part. Can't do it. When does sine x equal -0.31? Quadrant 3 and 4. Is that one of the angles that's on my special chart that I have memorized? Not a chance. So what do I do? No, it's easier than that.
You said second sign?
How do I get rid of a sine? What's the opposite of sine? Inverse sine. So x is arc sine of -0.31. And so you're right, I hit that inverse sine button on my calculator. So I do, there we go, sine inverse of -0.31, and my calculator tells me that that's -0.32, rounding to 2 decimal places. And that's the answer where? Quadrant 4. That's the answer in quadrant 4. also have to get quadrant number 3. Close. The answer in quadrant 3 would be x equals pi plus positive 0.31. Why is it x? Why is it positive? That was going to be my question. Because it's always x plus the reference angle. And the reference angle is always a positive angle. So it's got to be x plus 0.3 or pi plus 0.31, which is approximately 3.45. All right, that one turned out to be much harder than I expected. I thought it would factor, but it doesn't. So when we come back on Monday, we'll solve some more equations. We'll start with one that factors, and you'll see what I mean, that I thought it was going to be easier than that.